Hello everyone, today we are going to be talking about the properties of powers. And before we really dive into their properties, we are going to do a bit of a refresher as to what powers mean. When you have something like 3 to the 7th, it's really just a shorthand. It's telling you that we're taking 3 and we're multiplying it by itself 7 times. And that's all it means. So you could rewrite this as 3 times 3 times 3 times 3 times 3 times 3. And we've got here 6, one more. There we go. 3 times 3 times 3 times 3 times 3 times 3 is going to give us 3 to the 7th. Same thing with things like x to the 4th. Again, all this means is we're going to take x and multiply it by itself 4 times. 1, 2, 3, 4. Now the reason why they're doing this is this can take a very, very long time to write. This is really, really quick. And eventually we deal with numbers that have powers that are insanely high. So writing all of this out, this multiplication by itself, will take far longer and way more space than just doing a simple power. But the thing is, when you're dealing with powers, especially ones in the 7ths and onwards, they can get to be really large numbers, and we don't want to have to keep rewriting them in order to simplify problems and to find new solutions. So we want to see what we can do to deal with numbers when they're in the power form, and we're going to look at those properties starting today. So the first property that we're going to look at is multiplication. Like, what happens when you multiply two powers that have the same base? Now notice there are two warnings here. They need to have the same base and they need to be multiplication. Must have same base, must have multiplication. And this is because what we're going to be doing with our shorthand here is something like this. Let's say we have x to the 2nd times x to the 4th. Well, if I did x to the 2nd times x to the 4th, I could rewrite these as they are in multiplication. I know that x to the 2nd is x times x. I know that x to the 4th is just x times itself 4 times. And I know that between them is a sign of multiplication. So let's look at what I just wrote here. Now this whole thing can be simplified. What I have is all multiplication of the same number, and that number is x. And I know that if I have multiplication of the same number, I can write it as a power. So I have 1, 2, 3, 4, 5, 6 x's. So I could just say take x, multiply it by itself 6 times. Now I don't want to have to rewrite this every time. So let's look at the pattern here. What I've essentially done is I've taken x to the 2 plus 4. I've added the powers to get my final answer of x to the 6. You can try this out with a few other things, but it stands to reason that this will work every time because you're just saying how many times you're multiplying something in total. 2 times here and 4 times here, so a total of 6 times. So that means we can write our shortcut as x to the a plus b. That's going to be our rule. When you multiply things with the same base, and you're going to get an answer where you're adding the exponents. Now watch out, this will not work if you have addition, because if there's an addition sign, these are unlike terms and they cannot combine. You can only combine them if they are multiplication. And this won't work if there are different bases, because this will not summarize different bases. So let's try these out. We've got 5 to the 5th times 5 to the 8th. Well, all I have to do is 5 to the 5 plus 8, which is 5 to the 13th. Over here I have -2 times -2 to the 4th. Well, if you don't have an exponent written, what you're really saying is we only have one of those numbers. In other words, it's not really multiplied by anything, it's just is itself 1. So we have -2 to the 1st times -2 to the 4th, which is going to give me -2 to the 5th. Here we're going to be multiplying 3 things with the same bases together. So what I can do is I can take that shortcut. I can do x to the 2 plus x to the third, and then add that fourth from the last one over here. 2 plus 3 is 5, plus 4 is 9, so I end up with x to the 9. With these ones, I have negative b to the second times negative b. Again, if there is no exponent, it is to the first power. So this is going to be negative b to the 2 plus 1, or negative b to the third. Last but not least, I have some parentheses around this y, but no parentheses around this one. Can I still combine them? Well, yeah, because all this is saying is you have 5 y's multiplied together, and you are going to combine them with your y to the third. Now here what we're going to end up with then is, essentially we're saying we have y to the fifth times y to the third, or we're saying y to the fifth times y to the third. It doesn't matter, they have the same base, so I can combine the exponents with addition, x to the 5 plus 3, which gives, or y to the 5 plus 3, which gives us y to the 8th. Just as a quick check, let's remind ourselves whether or not we can use this shortcut for all of these. Well, here we've got a to the first plus a to the sixth. Can I combine these? Can I simplify them? And the answer is no. These are unlike terms, and unlike terms cannot be combined with addition. So you just write no and you move on. This is as simplified as it could be. It would be your final answer. For the second one, we have x times x to the second. Well, these are unlike terms, but unlike terms can be combined using multiplication, because remember, this is saying x to the first times x to the second, or x to the first one time times x squared, which is x times x. And that leaves us with x to the third. Last but not least, we have x to the third times y to the second. Can these be combined? Well, no, because they have unlike bases. Here, if I wrote this out, I've had x times itself 3 times, and I also have y times itself 2 times. Well, this doesn't really combine because these are unlike things. I can't just say x to the fifth or y to the fifth, because I'd be missing one of the variables. So leave it as your x to the third times y squared and move on. Speaking of moving on, we do have a few other rules to look at. What do you do when you have a power of a power? So here we have x to the a, and the whole thing is raised to another power. Well, let's try this out real quick. Let's say that we started with x squared, and we raised this to the fourth power, x squared, and we raise this to the fourth power. Well, if we did this, think about it this way. You're saying that everything inside of here needs to be multiplied by itself 4 times. So I'm going to have 1, 2, 3, 4, right? And each one of these things is x squared. Also, what we could say is, well, I don't want to write this as x squared. I really want to write this as x times x. So here what I'm going to end up with then is, for each one of these, I'm going to write x times x. I'm actually going to do it right above, and I'm going to remember I'm going to have 4 sections of these. Let's just write x times x in each of those. X times x, x times x, x times x, and x times x. Now here, since everything is being multiplied, it means I can combine it with powers. And what I can do is I can count up how many I have here. 1, 2, 3, 4, 5, 6, 7, 8. So this really results in x to the 8th. Now that's a pretty long translation. That takes a long time. So we'd really like the shortcut. And notice all we're really saying is that we have 4 of something that's multiplied by itself 2 times, or 4 times 2. And 4 times 2 is 8. That's why we get x to the 8th. So our rule here really is we're going to take x to the a times b. And I kind of like to think of this as, this is going to be the superpower. A power to a power gives us a superpower. Multiplication is going to be bigger than the addition 1. So you can try these out. You can, of course, do it the long way. I could say I'm doing 3 to the third 2 times, so 3 times 3 times 3. There's one of them. 3 times 3 times 3. There's 2 of them, which gives us 3 to the 6. Or you can just do, well, we've got a power to a power, so it's going to be 3 times, or 3 to the 3 times 2, or 3 to the 6. That means here we can take that shortcut. P to the 4th to the 5th power is p to the 4 times 5, or p to the 20th. What about something like this? Well, what this is just reminding us of is we technically do have a power to a power here. We have q to the 1st raised to the 5th power. And q to the 1 times 5 is just q to the 5, because 1 times 5 is just 5. So you can always remove those parentheses provided there's only one thing inside of it. You do have to watch out, of course, for negatives, and we're going to look at this one in just a little bit more depth. Here we have negative 6 times b squared. Now remember that what this is saying is you take the entire parentheses, negative 6 times b, and you multiply by it itself, negative 6 times b. Now, when we're doing multiplication, we are allowed to multiply in any order that we want. So I'm going to take the negative 6 times the negative 6, which is going to give me 36, and I'm going to take the b times the b, which gives me b squared. You can also see that there's a bit of a shortcut going on here. What I've really done is I've taken that negative 6 and I've squared it, and I've multiplied that by my b's squared. I have 2 b's and 2 negative 6's multiplied. Now I did lose my negative because if you multiply a negative by a negative, you will get a positive, so any negative raised to a even number will end up with a positive result. But I could have just as easily left this as 6 squared b squared, which leads us to a new rule. You are allowed to distribute the power within the parentheses as long as it's all multiplication. Now you have to be very careful here. This will not work if there's addition, because if I had an addition sign here, I wouldn't be able to get rid of those parentheses. I'd have to distribute, which is a whole nother rule, and we'll look at what that looks like later on. For now, just remember you are allowed to distribute. So that makes number 5 a lot easier. I can do 4 to the 3rd times y to the 3rd times z to the 3rd, and I would be done. Here, when I have 2 times w to the 3rd, all raised to the 6th power, I can distribute, so I have 2 to the 6th, and then I have w to the 3rd to the 6th, because I'm raising that to the 6th power. Well, that means that I'm still going to have 2 to the 6th, but here I have w to the 3rd times 6. So that's going to give me w to the 3 times 6, or w to the 18th. Remember that you can also move things around a little when you are doing multiplications and powers, so watch that you can combine the rules and keep track of them even when it's not structured as a simple problem like this. So here, if everything is multiplication, there's no addition, there's no division, nothing, I can move things around. So I'm going to take my 3 and my 2 and put them first, because coefficients are kind of nice in the front. We can multiply them together and make them neat. Then I'm going to put my x's together next. I've got x to the 7th times x to the 5th. Let's double check our rules here. I know when I have multiplication normally, well, I can just multiply together. Don't forget, this isn't suddenly addition. These are normal numbers being multiplied. So 3 times 2 is 6. Here, I've got exponents. Now, when I have exponents with the same base that are being multiplied together, I can combine using addition. So this is 7 plus 5, or 12. So my final answer, the simplification, would be 6 times x to the 12th. And you can do the same sort of thing with this mess. What you're going to get is you're first going to distribute, and then you're going to combine your x's. So you will have 4 to the 3rd times x to the 6th times x to the 5th, which gives you 4 to the 3rd times x to the 11th, 6 plus 5.